All right, today we are diving into a totally new, kind of radical story about where all the stuff in our universe really comes from. Everything from the iron in your blood to the phone in your hand. And it turns out the main character in this whole epic story is gravity itself. So let's start with a really simple question. Think about a piece of gold, maybe a ring or a necklace. For years, we've been told a story that it was all forged in the heart of a giant exploding star. But what if that story is missing its most important, most dramatic chapter? The real origin story is way more ancient and way more violent than we ever imagined. So, to really get this new story, we first have to understand why the old one it just fell apart. For decades, scientists were staring at this huge cosmic accounting problem. Okay, so this lays out the puzzle perfectly. On one side, you have the story we all learned in school. Supernovae, right? These spectacular star explosions were supposed to be the universe's ultimate element factories. And look, they're great at making stuff like iron, but here's the problem on the right side. When scientists actually ran the models and did the math, the books just didn't balance. There was no way these explosions had enough firepower to create all the gold and platinum we find in the universe. There was, quite literally, a universe of missing gold. The first huge clue to solving this whole mystery didn't arrive as a flash of light, nope. It came as a ripple, a tiny vibration in the very fabric of space-time. It was an echo from one of the most violent events humanity has ever witnessed. Back in 2017, the LIGO detectors felt it. Gravitational waves from two neutron stars spiraling into each other at incredible speeds. Immediately, telescopes all over the world swiveled to watch the aftermath, this absolutely cataclysmic explosion they call a kilonova. And inside the light from that blast, scientists saw it, the unmistakable chemical fingerprints of gold, of platinum, and other heavy elements being forged right there in real time. So here's the takeaway, the crucial point. The most powerful gravitational collisions we can see are also the universe's most powerful element factories. Okay, so this discovery gave us a profound new rule for the cosmos. But of course, it also opens up this completely mind-bending question. If the gravitational collisions happening today are making heavy elements, what about at the very beginning of time? What were the absolute first and most powerful collisions the universe has ever known? The answer takes us way back, to an era before a single star had ever ignited. So you have to try and imagine this. A universe that's completely dark. No stars, no galaxies yet. It's an ancient cosmos populated by these strange, invisible titans that were born from the chaos of the Big Bang itself. So, meet the primordial black hole, or PBH. Now, these are not the black holes we usually talk about, the ones that are left over from dead stars. No way. According to the theory, these things are actual fossils from the very first moments of creation. They formed when random, super dense pockets of the early universe just collapsed on themselves, long before stars were even a thing. They are the universe's original heavyweights. And this timeline just shows how wild this idea really is. I mean, look at the timing. Primordial black holes could have formed and actually started merging with each other within the first millionth of a second after the Big Bang. This is happening before the universe was even done creating the most basic elements, like hydrogen and helium. So it suggests that while the universe was sort of calmly cooking up the basics, these primordial monsters were already smashing into each other in the background, unleashing gravitational waves of unimaginable power. And this is where the whole story just clicks beautifully into place. If those first, most violent collisions were happening way back then, and if we know violent collisions forge heavy elements, then that might mean that gravity itself is the ultimate author of the periodic table. And this table just illustrates this new, unified picture so perfectly. You can basically sort the entire periodic table by how intense the gravitational event was that created it. So right at the bottom, with no violent gravity waves, the Big Bang gives us the simple stuff, hydrogen and helium. Move up a step, and you get medium-intensity waves from supernova, which are great at forging iron and nickel. Then you get high-intensity waves from those neutron star mergers we saw. That gives you silver and other heavy stuff. But right there at the very top, in the realm of extreme, almost unimaginable gravitational waves, that's where you find the mergers of primordial black holes. This might be the only cosmic event violent enough to be the main source for the heaviest, rarest elements we know, like gold and uranium, seeding the entire universe with them before the first stars were ever even born. This one sentence just captures the entire paradigm shift. It's perfect. We used to think of chemistry and gravity as these totally separate forces, but this new model suggests they are deeply, fundamentally connected. The history of the elements is really the history of gravitational waves. Now look, this is an absolutely incredible idea, right? It's beautiful. But is it actually science? You bet it is. Because this theory makes very specific, testable predictions. We don't just have to imagine it, we can actually go out and look for the evidence, for the cosmic fossils these ancient collisions left behind. And here is the actual roadmap for the hunt. First, we can use an instrument like the JWST to peer deep into the past, at the universe's first galaxies. If we find elements like gold or platinum there, before stars had enough time to make them, well, that's a smoking gun. Second, we can listen for a constant faint background hum of gravitational waves from all those primordial mergers. Third, we can study the oldest stars in our own galaxy, looking for weird chemical signatures that can only be explained by this early seeding. And finally, we can scan the faint afterglow of the Big Bang itself, looking for tiny imprints these violent events might have left behind. So the next time you look up at the night sky, just remember, you're not just looking at stars. You're looking at a universe that was shaped, sculpted, and chemically carved by the echoes of ancient, violent collisions. This completely transforms gravitational waves from just a cosmic curiosity into a kind of Rosetta Stone for understanding where we and everything around us truly came from. Which of course leaves you wondering, what other incredible cosmic secrets are still hidden out there, just waiting for us to hear them in gravity's waves?